Hello everyone. So today we are going to see something related to DP with binary search. Okay, so we have already learned about binary search, but oh, today we are going to see DP with binary search. Now, first of all, I wanted to cover one problem which is asked in Deshaw's coding test. Okay, uh, when Deshaw came for my college placements. So I got this question way back, like 4 years back. But Deshaw's coding test, it was asked, and it was literally I felt like a hard question at that time. But when I started solving with these templates, it feels like okay, this is a simpler question. You just need to know this template, and you are done. Okay, and another question we'll solve it is DP with binary search type of question, and I'll going to put some of the questions for your practice in the description, so please go through that too. Okay, so the first question, let me just paste the question directly over here and then we can think over it. Okay, so the question says that you are given an integer array nums and you want to maximize the number of points you get by performing the following operation any number of times. Pick any nums of I and delete it to earn this nums I points. Afterwards, you must delete every element equals to numsci minus 1 and every element equals to numsci plus 1 and return the maximum number of points you can earn by applying the above operation some number of times. So after applying some number of times, what is the amount that you have earned? So we have an example, this nums is equal to 2, 3 and 4. Okay, so what do we delete first? Let's say if I delete 2, then I have to delete 3. Okay, and then I'll delete 4. So what I'll get is 6. What if I'll delete 3 first? Then of course 2 and 4 will be deleted by itself and my scoring point is 3 only. Or I can delete 4 first and 3 will be deleted automatically and then I can delete 2. So again it's a 6. So these are the three possible combinations and my max earn I get is 6. So it's like choosing of which number to delete, because once you delete a particular number, its minus 1 and plus 1 will be automatically deleted. Okay, its minus 1 and plus 1 will be automatically deleted. Now, for this particular number, also, you have a choice. Like, what choice? Whether to delete or to not delete it. Okay, you have this choice of whether to delete or to not delete it. So, it's like a choice of taking it means deleting it or not taking it. So, we'll use DP over here. That way, we will realize that, okay, I have to use DP. And one another point is like it was given, you have to make maximum number of points. So, you have to maximize this. So, you have to delete. Now, from where will you start? Like from which number you will start? You can either go in ascending order, like mini to maxi, while deleting, or maxi to mini. Now, you cannot pick any random number. You have to fix some way to choose. Like you can either go from mini to maxi or from maxi to mini. Okay. Now, your DP state should have how many variables? So, what are your variables? Of course, your number, right? Now your number could be this numbers, could be this numbers, but you didn't know what all numbers are present. I mean, array is given, but how you will decide on this? So whatever is your nums value given, let's say maximum value is 1 is 6, you have to make the DP of that size. So DP of, let's say, 1 is 6 plus 5 you will make. Okay, and let's say I'm going from mini to maxi. Now, there could be case like 2, 2, 3, 4, 4. Okay. So, I'll delete 2 first, then 3 will be deleted automatically. Then I'll delete this 2 again, and no one will be deleted. So, 2 plus 2. I'll delete 4, and 4 will be added. No one is deleted. I delete 4 again. So, it's like how many times the particular number is present, that also you need to store. So, for that, simply we use what? Map to store frequency of the number. Because if you delete particular number of times it's present, you have to multiply that it with directly. Now our condition says that if you take that, when can you take? If it's present in map, then only you can take it. If it's present in map. add that frequency. Okay, let's say 4 is 2 times, then add 2 into 4 plus. Now again you have to go for num plus 2 only. Why I'm not going num plus 1? Because plus 1 will be already deleted. And why am I not checking for minus 1? Because I'm following this pattern of mini to maxi. So of course minus 1 will be deleted previous to that if it was existed. Now it won't exist at all. I'm following one pattern only. If you follow this pattern, then you have to go num minus 2. Again, depends on you that what pattern you're following. Okay, I'm following mini to maxi pattern. Fine. And if I want to take it, I'll simply go to num plus 1. That means I have to delete num plus 1. If it is present in map, not present, that I will check in that round. Okay. If it is present, then only we'll take. Otherwise, of course, one option only not to take. Now, what is your base condition? So you have passed initially your minimum number in this num. Okay. And your maxi also you will pass. So if your this num becomes greater than maxi, then you will stop. You will return 0 from there. So this is your base condition, right? Because anyways, your number should not go beyond maxi. Max is the only maximum number you have in your nums array. I hope you got this. I hope you got this. And we will store in the map all the elements, okay? Fine. Then let's solve it and you will get a better idea of that. Okay, so I'll share this tab. Fine. Okay, and let me make one map, an ordered map of int comma int, call it as map, and I'll have two variables. Okay, initially int mini is 0 and maxi is 0. So what are the possible numbers we could have? Num size could be from 1 to 10 raised to 4. Okay, then constant static constant n is our 1e4 plus 5, and I'll make a dp of size n. Okay, only one variable is changing. Fine. You will traverse through each of this element for auto ampersand element in nums. I'll do map of element plus plus. I'm storing frequency. Now maxi is equal to max of maxi comma element, and mini I'll put okay 1e4 as of now. Okay, so mini is minimum of mini comma element. Okay, and I'll call my solve function with this mini as my initial num and my maxi as my maximum value. Now I have int solve, int num. This is my current number. Okay, and I have one maxi also. Okay, and you need to pass the map also. Okay. What does dp of I state stores? That dp of I stores max points by taking elements from ith number, not index. This is not index. If we take the index over here, it's very difficult for us. Okay, because we have to operate on the sorted manner, like nums maxi to mini or mini to maxi. If I take randomly like 3, I need to check like whether I should take 3 or not. If I'm taking 3, I have to go and check for plus 1 also, minus 1 also, and delete both of those without adding their points. And that is a critical operation. So we are taking numbers over here. So max points by taking elements from ith number to maxi number. Okay, fine. Okay, so if my num is greater than maxi, return 0. Cool. If dp of I is not equal to minus 1, return dp of I. Now you have not take condition simply, wherein you will just go to num plus 1. That means you didn't want to delete num, or it's not present. It could be any situation. This remains maxi and map. If map dot find this num not equal to map dot end, means You have this number, you have this number, okay? Initially, I'm taking my take as 0. So what I'll do, I'll update this take as I'm number of times it's present in element, multiply this number, and I'll go to plus 2. This all remains same. And return dp of I as maximum of tick comma not tick. Cool? Simple. Simple question, but it's asked in Deshaw and many of the folks of my batch wouldn't be able to solve it. Okay. Oh, this is dp of num. If dp of num is not equal to minus 1, return dp of num, and this is also dp of num. I hope you got this. And it's a very famous question which was asked in our time at the Deshaw. Okay, we need to return this. Okay, so this is a simple question now. After we got this pattern, so you just need to take care that okay, here you don't have to take the index. If you will take index, you didn't have any option whether to go for I plus 1 or not to go. Okay, but if you take number, you have the correct choice of whether to go or to not go. So that is the critical point wherein the people fail. Okay, now we'll solve another question, which is DP with binary search question. Let me paste the question to our editor. Okay, so the question says that you are given an array of n pairs where pairs of I is equal to left eye, comma right eye, and left eye is lesser than right eye. Okay, a pair P2 is equal to C comma D follows a pair P1 which is equal to A comma B if this B is lesser than C. A chain of pairs can be formed in this fashion. Return the length of the longest chain which can be formed. You do not need to use up all the given intervals. You can select pairs in any order. Okay. So one of the example which I could paste here is this. Okay. So let's say you are given this pairs 1 comma 2, 2 comma 3 and 3 comma 4. So you didn't have to choose all the pairs, but you have to make such that it's the longest pair. Now I cannot choose 2 comma 3 and 3 comma 4. Why? Because this is the B for my pair P1 and this is the C, like here given, of my pair P2. Now B is not lesser than C, so this could be merged to 2 to 4. This could be merged. These are not independent pairs, I could say. Okay, so I cannot make this pairs of longest chain. What I could make is I could make 1 comma 2, 2 comma 3 I cannot add. Then and directly I can add 3 comma 4. This is one of the possible pair. Otherwise, only 2 comma 3, only 3 comma 4, only 1 comma 2. Okay, so the longest length I am getting is 2, which I could make out of this 3 pairs given to me. Now, what can I do? For this type of questions, of course, you need to sort it, whether according to the first value or second value. Now, you need to decide what you have to do. Okay, you know wherein the DP applies, whether to the pair, take pair, or not take the pair. You have only two conditions, whether to take the pair or to not take the pair. Now, what you will do? You will take the pair or you will not take the pair. If you will take the pair, let's say I have taken this 1 comma 2 pair. Okay, I have taken this 1 comma 2 pair. Now wherein will I go? Will I go to 2 comma 3? No, I have to go to 3 comma 4 only. So I need to find such an index wherein my start value should be at least greater than my ending value of the current pair. I hope you got. The start value of the next pair which I'm going to choose should be greater than the current value's ending value, current pair's ending value. So that means I need to apply some upper bound kind of thing. Now, upper bound kind of thing for what? So I'll apply the upper bound for 2. Okay. I'll apply the upper bound for 2. So I have this 1 comma 2, 2 comma 3, and 3 comma 4. Okay. Now we have sorted it according to the first value. So this is already sorted according to first value. Sorted according to first value because we want to take as max values as we can. So it's better to sort according to first value. What if you sort according to second value? Okay, what if you sort according to the second value? Lowest second value, of course, is the lowest first value. Okay, of course, is the lowest first value. So it's better to sort according to the first value. You can sort according to second value also, wouldn't be an issue. So try doing that too. Okay, for this question at least. Now what I'll do, I'll store my first values in one of the array, a separate 1D array. Because I have to find that index, let's say 3, that okay, after this 2, I have to take this 3. So I'll apply upper bound on my start array index, on my start array which I have created for value of the ending value of current pair. So I'll apply upper bound on this particular array for the value 2 which I got as the ending value of my current pair after taking 1 comma 2. So I'll get to know that okay, what is the next greater value? So this index 2 is I have to take. So I'll go directly to that index. If I am taking current value. If I'm not taking, of course, I'll go to I plus 1 only. Right? Fine. Let's solve it now. This is a simpler question. And there are another question which I'll put in the description related to the binary search. Okay. So DP, of course, is related to the index over here. So we have 1000 indexes. So I'll make into DP of 1005. Okay. Fine. Now we need to sort this according to the first value. So I can sort the pair itself. Pairs dot begin, pairs dot end. Now I have to make one start array. So vector of int start of size n. This n is pairs dot size only. And what I'll do is for auto ampersand element in pairs, I'll give my start of I as element of 0. Or sorry, element of 0. Because this is not pair. They have given it as in the form of vector of vector. So cool. Okay. And this should be already sorted because we have sorted the pairs first only. Fine. So now we have int solve, which has int I, a vector of int ampersand start, a vector of int ampersand pairs, and int n. Okay. Now if my I is equal to n or greater than equal to n, I'll return 0 because I could not add any length over there. Okay. If dp of I, so dp of I again here is from ith value to end value, from ith to nth. dp of I, because we will pass I as 0. So max length by taking pairs from ith index to nth index. Okay. So if dp of I is not equal to -1, return dp of I. I need to memset this also. Memset dp -1 size of dp. Okay. Now what? You have two options, whether to take or to not take. Okay. Now first, let's take it. So if we take it, okay, if we take it, my length will be increased by +1 and I need to find the index. So I'll find first index. So if I'm taking the current value, I need to find the index. So I'll do upper bound on start array. Start dot begin, start dot end, comma, for what value? For my pairs I comma 1 ending value minus start dot begin. So I'll get the index. So if I'm taking it, I'll do 1 plus and I'll go to this index value again with the start pairs n. But if I'm not taking it, I can simply go to I plus 1 index. Sorry, this could be I plus 1 index start pairs n. And my dp of I is again maximum from take comma not take. I hope you got this. This is very simple. I'll solve 0, start, pairs, and end. Okay? The simpler, just you need to use this upper bound function, and it's done. Okay. Oh, fine. Let's do for int I0 till I less than n I plus plus. Start of I is equal to pairs of I comma 0. Okay. Because we have initialized start with n size, we need to do that. I hope you got this. Okay, so in the next video, now I'm going to cover all problems related to subset related problems, which is specifically of the knapsack DP type. So stay tuned until that. Do like, share, and subscribe if you have learned a lot of